class. So in today's class, we are going to start the NCRT exercise of class 9 sound chapter. And question number first is, what is sound and how it is produced? So what is sound? We all know that sound is a form of energy which enable us to hear, or sound is a form of energy which give a sensation of hearing. So we know that what is sound, but how it is produced. So, in the chapter sound, we have studied that sound is produced by the vibrating body. So, any body which vibrates will produce sound. Okay, so let's see its complete explanation. Sound is produced due to vibration. When a body vibrates, it forces the adjacent particle of the medium to vibrate. This results in the disturbance in the medium, which travel as the wave and reaches the ear, hence sound is produced. So this is an object which is a source. Okay. So source is vibrating and it is creating disturbance in the surrounding. Okay. So it is creating disturbance in the surrounding. So this particle will start vibrating. It will transfer its vibration to adjacent particle and it will stops and this particle will start vibrating, and this vibration will transfer to other particle, then other particle will transfer its vibration to other particle, and that's how sound travel and sound is produced by vibrating body or vibration. Is this question clear to all of you? Now we will move to next question, question number 2. Question number 2 asks that describe with the help of diagram how compression and rarefaction are produced in air near a source of sound. So we have to draw the diagram of compression and rarefaction near the source of sound, and the medium is air. When so the answer of this is, when we have studied the example of a school bell. So when a school bell is hit with a hammer, it moves forward and backward, and this school bell, which is a large metallic disc, will start vibrating and it will produce the vibration of the metallic bell will produce a compression and rarefaction region in the medium. Okay, so the compression region will have high pressure and the rarefaction region will have low pressure. The high pressure region is known as compression, and when the vibration is moved backward, then it will create a low pressure region in the surrounding, and this region is called the rarefaction, and this is the diagram. A object is vibrating and creating a series of compression and rarefaction region in the medium, and that's how sound wave propagate. So in this question, we have to draw this diagram. Clear, class? Now we will move to next question. Next question is, why is the sound wave called longitudinal wave? So in the class, I have explained to you that there are two type of waves. One is longitudinal wave and another is transverse wave. So the question is, why is sound wave called a longitudinal? What will be the answer of it according to you? So in theory part, I have explained that okay, the disturbance and the propagation of sound is in same direction. And when the disturbance and the propagation is in same direction, that those type of wave are called longitudinal wave. So explanation is clear. Its detailed answer is, the vibration of the medium that travel parallel to the direction of wave or along the direction of wave is called longitudinal wave. This is the definition of longitudinal wave. Now, why sound is a longitudinal wave? Because the direction of particle of medium vibrates parallel to the direction of propagation of disturbance. In the direction in which particle vibrate is parallel to the direction of propagation of disturbance. So the sound wave is called a longitudinal wave. Is it clear, class? So now let's move on to next question. Next question, question number 4 is, which characteristic of sound help you to identify your friend by his voice while sitting in with other in a dark room? Let's imagine you and your friend with other classmates are sitting in a dark room. Okay? So now which characteristic will help you to identify your friend's voice even you are not looking at your friend? So we have already discussed this type of thing in the theory part, that there is a term called quality of sound which include loudness, pitch and how better the sound is, and this help us to differentiate one voice from other voice. So this question answer is quality of sound. Quality of sound is a characteristic that help us to identify the voice of particular person. Two people may have same pitch and same loudness, but their quality of sound will be different, and quality of sound will help you to differentiate between two different voices of two different person. Is this answer clear to you, class? Now let's move on to next question. Next question is, flash and thunder are produced simultaneously, but the thunder is heard a few seconds after the flash is seen. Why? We have also discussed this topic in the theory part. The question is asking that two clouds are collide and you will first see the thunder. Okay, thunder. Then you will hear, first you will see the flash, then you will hear the thunder noise. Why you first hear the flash, then thunder? Explain it. And in class, we have discussed that flash is light and thunder is sound. The speed of light, which is represented by c, is 3 into 10 raised to the power 8 meter per second. And speed of sound is approximately 300 meter per second. So it is clear that the speed of light is very, very much greater than speed of sound. That's why the light travel faster in our eye in comparison to sound travel to our ear. That's why we first see the flash, then we hear the thunder noise. Okay, the speed of sound, this is the correct value. Approximately we take 300 meter per second. So the speed of sound is 300 around 344 meter per second in the air, where the speed of light is 3 into 10 raised to the power 8 meter per second. It is a very large number, and in fact, speed of light is the fastest speed any object can have. So speed of light is very, very much greater than speed of sound. So that's why we first see the lightning, then after few seconds we hear the thunder. Due to this reason, the speed of light is very, very much greater than speed of sound. Thunder take more time to reach earth as compared to light speed, which is faster. Hence lightning is seen before whenever we hear thunder. Before thunder, we see the lightning because the speed of light is very, very much greater than the speed of sound. I hope this answer is clear to you. Now, next question is question number 6. A person has hearing range from 20 Hz to 20 kilohertz. What are the typical wavelength of sound waves in air corresponding to these two frequencies? Take the speed of sound in air as 344 meter per second. So what question is asking? Question is asking that a person has a hearing range. Okay. We have hearing range of 20 hertz to 20,000 hertz. Okay. What will be the wavelength between these two frequencies? So frequency number 1 is 20 hertz. Frequency number 2 is 20 kilohertz or 20,000 hertz. Okay, and we have already given the velocity or the speed of sound in the air as 344 meter per second. We have asked what will be the wavelength range. So we have to calculate wavelength minimum to wavelength maximum. We have frequency, we have velocity, how we will calculate the wavelength. What will be the formula used? Formula used in this question will be speed is equal to frequency into wavelength. We know the speed, we know the frequency, we can easily calculate the wavelength. So let's see the detailed solution of this problem. For sound wave, speed is equals to wavelength times frequency or V equals to lambda nu. It is given to us that the speed of sound in the air is 344 meter per second. Okay. For frequency 20 hertz, the wavelength lambda 1 will be V divided by nu. V is 344 divided by 20. Wavelength is 17.2 meters. And now for frequency number 2, which is 20,000 hertz, the wavelength will be speed divided by frequency 344 divided by 20,000, which is equal to 0.012 meter. So our hearing range is from 20 hertz to 20,000 hertz or 20 kilohertz, and the wavelength which we can hear is from 0.0172 meter to 17.2 meter. This is our hearing wavelength and this is our hearing frequency. Hearing frequency, hearing wavelength. Okay. So I hope you have understand this problem. Now let's move on to next question. Next question is, two children are at the opposite end of an aluminum rod. One strike the end of the rod of a stone. Find the ratio of time taken by the sound wave in the air and in the aluminum to reach the second child. This is one long aluminum rod. Okay. Two children's. One child is in one end of the aluminum rod and another child is on another end of the aluminum rod. Okay. This child has a stone in his hand and he hit the aluminum rod. Now, how much time it will take to this noise to travel to this person? So, we have to calculate time in air divided by time in aluminum. Okay. Now, you will ask that no other information is given. How we can solve it? So, we know the speed of sound in air, which is 344 or 346 meter per second. Okay. And from the table, we know the frequency speed in aluminum, which was around 6420 meter per second. So we know the speed of sound in air. We also know the speed of sound in the aluminum. We can assume that the distance or the length of this rod is d. Now we know that distance is equal to velocity into time, or time will be equal to distance divided by velocity. And by applying this formula and using these information from the table, we can calculate the T air divided by T aluminum. So let's see the detailed solution. I hope the approach is clear to everyone. So let's consider the length of aluminum rod as d. Now the speed of sound wave in aluminum is 6420 meter per second, and we know that the speed uh, velocity or speed is equal to distance divided by time, or time is equals to distance divided by speed. So we can calculate the time in aluminum, which is distance d divided by velocity in aluminum, which is 6200 and 6420. Now we know that speed of sound in air is 346 meter per second. So the t in the air is distance divided by velocity in air, which is t divided by 346. Now t in air divided by t in aluminum will be t in air is t divided by 346 divided by t in aluminum is d divided by 6420. Now let's simplify it. This d will come to this place and this term will come to this place, which will be equal to d into 6420 divided by d into 346. From d to d cancel, which is equals to 6420 divided by 346. And when you will solve this quantity, the final result will be 18.55. So the ratio of time in air divided by time in aluminum is 18.55. Is it clear, class? Okay, I hope this question is clear to all of you. Now let's move on to next question. Next question, question number 8 is the frequency of source of sound is 100 hertz. How many times does it vibrate in a minute? So given, what is given to us? Frequency is 100 hertz. Time is 60 second or 1 minute. Okay. And what we have to find? We have to find number of vibration. We have to calculate number of vibration n. How we can solve this question? What will be the formula used? Formula used will be frequency is equal to number of oscillation or number of vibration divided by time period t. We know the frequency, we know the time period, we have to calculate the number of vibration. So the number of vibration will be frequency into time period. We will put the value of frequency and time period and can calculate the number of vibration or the number of oscillation. Is it clear, class? So let's solve it. So frequency is number of oscillation divided by total time, or number of oscillation is equals to frequency into time. Frequency is given as 100 hertz and time is given as 1 minute, which is equals to 60 seconds. So number of oscillation will be time period multiplied by frequency. Frequency is 100, time period is 60. So number of oscillation is 6000. So if a source has frequency of 100 hertz, so in 1 minute it will generate 6000 oscillation. The source vibrates 6000 times in a minute to produce a frequency of 100 hertz. Is this question clear to you? Now next question is Question number 8. Does sound follow the same law of reflection as light does? And the correct answer is yes. Light follow two laws of reflection. One is angle of incidence, angle of reflection, and normal lies in a same plane. And second is incident angle, angle of incidence is equal to angle of reflection. And from that chart paper, one example, we have learned that yes, sound also follow the same law of reflection as light does. So yes, sound follow the same law of reflection as light. And what were those two laws? One was angle of incidence is angle equal to angle of reflection, and law number 2 was incident ray, normal ray, and reflected ray lies on the same plane. Okay, reflected wave, normal, and incident sound wave all lies in the same plane. So sound also follow the same law of reflection as light does. Now let's move on to next question. Question number 10. When a sound is reflected from a distant object, an echo is produced. It is clear to us when sound is reflected from a large distant object, echo is produced. We can hear the echo. Let the distance between reflecting surface and the source of sound produce the same reflection. So one day you come near a cliff and you can easily hear the reflection. Next day, the day was hotter, the temperature increases. Will you be able to hear the echo? Do you hear able to hear the echo on a hotter day? What will be the answer according to you? So we know that the speed of sound increases as temperature increases. Is it clear? And to hear the echo, the difference between reflected ray and incident ray should be 0.1 second. Okay. If temperature increases and velocity of sound will increases, then the gap of 0.1 second will decrease. And because the gap will decrease, we will not able to hear the echo. Okay. So the correct answer is an echo is heard when the time interval between the reflected sound and original sound is at least 0.1 second. Okay, as the temperature increases, the speed of sound also increases. On a hotter day, the time interval between the reflected and the original sound will decrease, and because it will decrease, then the gap of 0.1 second will no longer exist. The gap will decrease, and we need at least 0.1 second gap. Okay, so correct answer is you will be not able to hear the echo. Okay, so in today's class, we have started the NCRT exercise of sound chapter and we have solved till 10 question. In next class, we will start by solving question number 11. I hope all the questions are clear to you. Now we will meet in next class. Thank you so much.